To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to continue with applications of transformers. So in the previous chapter I explained what transformers are. You can remember there are two coils, the primary coil or the input and the secondary coil or the output. So we need to supply an alternating current or a varying direct current, not a continuous direct current. It does not work with continuous direct currents. So there when you supply an input voltage, the voltage will be varied. The voltage can be either increased or decreased. So if the voltage is increased in the secondary coil or the output, we call it a step-up transformer. And if the voltage is decreased in the secondary or the output coil, we call it the step-down transformer. And we discuss the equation. Number of turns in the primary coil divided by the number of turns in the secondary coil is equal to the voltage supplied to the primary coil divided by the voltage difference in the secondary coil. So if you write it using symbols, NP divided by NS gives rise to VP divided by VS. So I said using that we can do calculation. I showed you all a very simple example when I explained the step up and step down transformers. But after this, after we discuss the applications of transformers, we will be again doing some calculations. So here, applications of transformers. So this is part of what we have discussed before. Now you all know this is the household. Now when we receive current to the household, you all know it is 230 volt, 50 hertz alternating current. But that is obtained from the distribution subcenters. So before that, the main national power grid supplies electricity to the distribution subcenters, and before that we have the places where the power is generated, the power generation centers. So there is a lot of transmission of power. You all know that, electricity. So alternating current electricity generated in electric power stations are stepped up to a high voltages such as 132,000 volts or 132 kilovolts or 220,000 volts, that is 220 kilovolt, using step-up transformers before supplying to the national power grid. So here step-up transformers. Now you all can remember, students, when we discuss dynamos, I told you all if it is a hydropower plant, so there when the water falls onto the dynamo rotates and electricity is generated. So there it is the dynamo, and the electricity that is generated is alternating current. And there you can see here in this diagram they have shown the power generating station. Here you can see power generating station. In the power generating station, it is the alternating current that is generated, and then there is the step up transformer. This is the step up transformer that converts the 11,000 volts or the 11 kilovolts to 220 kilovolt. And then you can see there is power transmission. Power is supplied, distributed throughout the area. Now, why do they need to increase the power? If they are to supply very low voltages, that would be very expensive. They will need very long supply cables. So, it's not very practical. Now, if they increase the voltage, it will be a very high power current. So that is easy to distribute and supply through the households. So that is why they need to increase the voltage. So to do that, they use step-up transformers. Then after the power transmission, You can see the power supply, power transmission. Now this is the diagram that shows the components. This is like a flow chart that shows you all what happens. So after power transmission, what happens here? 220 kilovolts, that is 220,000 kilovolts is brought down to 22 kilovolts. So it is a step down transformer. Step down transformer. Step down transformer, you can see the symbols. More coils in the primary, less coils in the secondary. Then there is the power distribution. So here these are the distribution cables. So before it is supplied to the household, again there is a step down transformer that converts 22 kilovolts to 220 volts. Then you receive the current to the household. Is that clear? So the power generating station, then the step up transformer, less turns in the primary coil, more turns in the secondary coil. It converts the 11 kilovolts to 220 kilovolts. Then there is the power transmission. After that, there is a step down transformer that converts 220 kilovolts to 22 kilovolts. Thereafter, power is distributed. While distributing, when it is about to be given to the household, supplied to the household, there is another step down transformer, 22 kilovolt to 220 volts. So here also you can see more number of turns in the primary coil, less turns in the secondary coil. Then the home or the household circuit receives the power supply. So to the household, you can't supply very high voltage because the devices, the electrical appliances in the household, they use less potential difference. But for transmission, the voltage has to be increased. So it is going to be efficient transmission of power. So because of that, after generating, before the electricity is supplied to the household, there are different stages where the transformer is used. Both step up and then step down transformers are used. You have to remember that. So, alternating current electricity generated in electric power stations are stepped up to high voltages such as 132,000 volts or 132 kilovolts or 220,000 volts, that is 220 kilovolts, using step-up transformers before supplying to the national power grid. Step-down transformers. Step-down transformers are used in power substations that distribute power obtained from the main power transmission stations to homes. So, what we discussed now. With that, students, I'll move on to the next slide. In order to obtain high voltages used in microwave ovens and X-ray tubes, step-up transformers are used. So, microwave ovens and X-ray tubes. Microwave ovens we use at home. There is a transformer in the power pack. So, because they need high voltage. So, because of that, there should be a step-up transformer used. Then X-ray tubes, they also need high voltage. So, for that also, they need high voltage step-up transformers. Now, you all know microwaves, there is microwaves generated within the microwave oven, and also in X-ray tubes, high energy X-rays are produced. So, for that, we need high voltages. So, you have to understand that. And also another application, they are also used in power packs and in electric appliances such as computers and radios. Now, computers and radios also use transformers. And also you all know they also use the alternate current to direct current rectifiers as well. So, there is the transformer and the rectifier. Everything is included in a power pack. You can remember that. So, these are all applications of transformers. So earlier we saw in the distribution of electricity to households, they use step-up transformer and step-down transformer. Then in microwaves and X-ray tubes, they use step-up transformers. The same way in power packs, again they use, for computers and radios, they usually use the step-down transformers. So like that, the transformers have various applications. Is that clear, students? So with that, I'll move on to the next slide. So here, energy relation in a transformer. Now the efficiency of an instrument is not 100% as they produce other forms of energy such as heat apart from what they are intended for. So why do they produce heat? You can remember normally the conductors have a resistance and part of the electric current is used up against the resistance. Because of that, there is heat generated. So normally, practically, there is no appliance or instrument that is 100% efficient. But to do calculations related to transformers, we consider that the transformers are 100% efficient. So in transformers too, all the energy supplied to the primary cannot be obtained from the secondary. However, we will assume here that there is no energy loss in the transformer. So we assume that there is no energy loss in the transformer. Then according to the law of energy conservation, efficiency will be 100%. The energy you supply to the primary coil will be obtained from the secondary coil if it is 100% efficient. Then the power of the primary coil is equal to the power of the secondary coil. Then the power of the primary coil is equal to the power of the secondary coil. Now you can remember the equation for power. Power equals VI. So that is power, voltage, current. Power equals potential difference into current. We have used this equation before. Therefore, the following relationship is obtained. Now we can get a relationship. The primary coil, the power you supply to the primary coil is equal to the power obtained from the secondary coil. Power supplied to the primary coil equal to the power obtained from the secondary coil. So potential difference you can remember V primary. Current we can denote it as I primary. V primary into I primary will be equal to V secondary into I secondary. So V primary into I primary equals V secondary into I secondary. Now here from this relationship, students, you all can see if it is a step up transform, V secondary will be greater than V primary. But since the equation is V primary into I primary equals V secondary into I secondary, when the voltage increases, the current will decrease because the energy remains the same. So here, from this equation, you need to understand that when energy remains the same, current decreases when voltage increases and current increases when voltage decreases. Is that clear, students? So, because the energy remains the same, now this is constant. So, you can see when Vp to Vs, Vs increases. So, the Ip to Is, Is should increase. Is that clear? So, in a step-up transformer, voltage increases, but the current output decreases. In a step-down transformer, voltage decreases, then the output current increases. So, you have to remember that. Step-up transformer, voltage is increased, but current is decreased. And in a step down transformer, voltage is decreased, then current is increased. You have to understand that, students. So, that is how the transformer functions. So, because if you consider the energy relations, power is equal to potential difference into current, that is VI. So, power supplied to the primary coil is equal to power obtained from the secondary coil. That is considering that the transformer is 100% efficient. So, from that we get this equation, V primary into I primary is equal to Vs into Is. That is potential difference of primary coil into current supplied to the primary coil is equal to voltage of the secondary coil into current obtained from the secondary coil. So, from that you have to understand when energy remains the same, current decreases when the voltage increases. And also current increases when voltage decreases. So, in a step-up transformer, voltage is increased but the current is decreased. In a step-down transformer, voltage is decreased, then the current is increased. This is something you all have to keep in mind. You will get a better understanding when we do the calculations as well. So, with that, I'll move on to the next slide. Here we have an example. A certain transformer has 500 turns in its primary coil. So, 500 turns in its primary coil and 5000 turns in its secondary coil. So, from the number of turns, you can identify it is a step-up transformer. So, 500 and 5000. The voltage difference of 12 volt is supplied to the primary coil. The first question, find the voltage difference of the secondary coil. So, what do? You don't really have to draw a diagram or anything. Since I am doing the first calculation, I will just show you all the diagram as well. So, we have the transformer like that. So here we have 500 turns, that is N primary, and we have 5000 turns in, that is N secondary. We supply the voltage difference of 12 volts, that is V primary. We need to find the voltage difference of the secondary coil. So that is a step up transformer. Step up transformer. So students, like I told you all, you don't have to draw all these just to calculate the voltage difference, but this is for you all to understand. So this gives a clear picture. Then, what is the equation we use? We write N primary divided by N secondary equals V primary divided by V secondary. So primary has 500 turns. Secondary has 5000 turns. Potential to the primary 12 volts. We do know the secondary voltage. So that is what we need to find out. If you rearrange the equation, you will get it as Vs equals 12 volts into 5000 divided by 500. So when you cancel off, this becomes 10 times more. So 12 into 10, 120 volts. So the output voltage will be 120 volts. Step up transformer. Is that clear, student? So then I'll move on to the next question. A certain transformer has 500 turns in its primary coil and 5000 turns in its secondary coil. A voltage difference of 12 volts is supplied to the primary coil. That is the same question. The second part, if a current, so here you can see, if a 2 ampere current passes through the primary coil, calculate the current in the secondary coil. So for this, what do we need to do? Now we use the equation for power. V primary into I primary equals V secondary into I secondary. Voltage into current, that is power. So here you can remember there are 12 volt is supplied to the primary coil. So 12 volt into 2 ampere current, that is obtained as 120 volts. We calculated it in the previous question. We need to find the current output, I secondary. So here again, if you rearrange, I secondary is equal to 12 volts into 2 amperes divided by 120 volts. So there, of course, you can see 12 and 120 10 times. So that is going to be equal to 2 over 10, 0.2 amperes. Now this is what I told you all before. When the potential increases, current decreases. Can you all understand that now? Now here you can see the potential increased, the current decreases. So step up transformer, voltage increases, current decreases. Is that clear? So the same question is repeated. A certain transformer has 500 turns in its primary coil and 5000 turns in its secondary coil. A voltage difference of 12 volts is supplied to the primary coil. And the third part of the question is, which type of a transformer is this? I already told you all, from the number of turns itself, we can identify that it is a step-up transformer. So it is a step-up transformer. Step-up transformer. Transformer. So this is an example related to step-up transformer, you were able to understand that the voltage increases, at the same time the current decreases. So in the next slide, I will do an example where we look at a step-down transformer. So here, if we consider a step-down transformer, now you can remember, students, step-down transformer, there are more turns in the primary coil, whereas in the secondary coil, there are less turns. So let's say there are 2000 turns in the primary coil, that is N primary, and in the secondary coil there is 200 turns. So we supply a potential difference of, let's say, 30 volts to the primary coil. So we will need to find out the potential difference that will be obtained from the secondary coil and also the current that is obtained from the secondary coil. So like we did before. So looking at this, you all know this is a step down transformer. So since it's an example, I'm not going to write it as a question. These are the information given to you. There are 2000 turns in the primary coil and a supply of 30 voltage is given to the input. Whereas you get the output where the coil has 200 turns, you need to find the output voltage as well as the output current. So if we do the calculation, what is the equation you use to find the output voltage? That is N primary divided by N secondary equal to V primary divided by V secondary. So N primary, there are 2000 turns, and in the secondary coil there are 200 turns, and the voltage supplied as input is 30 volts. We need to find the voltage of the secondary coil or the output voltage. So here, if we rearrange the equation, you will get it as 30 volts into 200 divided by 2000. So when you simplify, this becomes 10. So here again, you will get the output voltage as 3 volts. So here you can see 30 volts is reduced to 3 volts. That is the function of a step-down transformer. So what happens to the current? We need to find the current as well. Now the second one, we need to find the current. For that, what is the equation? V primary into I primary is equal to V secondary into I secondary. Voltage of primary coil multiplied by current input, that is equal to voltage of secondary coil multiplied by current output. So here, if we substitute V primary, you can remember 30 volts. And what is the current that is supplied? Here, okay, I have to give you the current. Let's say a current of 10 amperes is supplied. Say 10 ampere current is supplied to as the input current. Then we need to find the output current. So here, input current is 10 amperes. Then the secondary voltage is what? It is 3 volts. 3 volts into secondary current or the output current. Again, if we rearrange secondary coil, the current that will be drawn out will be equal to 30 volts into 10 amperes divided by 3 volts. So when you simplify these two, this is 10. Because of that, 10 into 10, you will get 100 amperes. Now can you understand that? Here you can see current is converted from 10 amperes to 100 amperes. So when the potential is reduced from 30 volts to 3 volts, current goes from 10 amperes to 100 amperes. That is a step down transformer. So in a step down transformer, voltage is reduced but the current output is increased. In a step up transformer, voltage is increased, the current output is decreased. So you have to remember that, students. And when you all are answering questions also, you have to keep that in mind. So if I repeat that again, you all can understand it. Transformers are used to convert the potential of a current. In a step up transformer, the voltage is increased, but the current is decreased. In a step down transformer, voltage is decreased and the current output is increased. You have to remember that. So with that, students, I have come to the end of this lesson. So in the next slide, I will discuss the summary with you. So, summary. The direction of the magnetic field existing in the vicinity of a current carrying conductor can be found using the corkscrew rule. You can remember the corkscrew rule, students. Corkscrew rule. Corkscrew is used to remove, open or close the lid. So when you have a corkscrew, if it is rotating in the clockwise direction, usually it is moving downwards. So the current flow is down, magnetic field will be in the clockwise direction. If you have a conductor like this, you will be rotating it this way. So the current goes downwards, the magnetic field will be clockwise. If you are rotating the corkscrew upwards, then it is an anti-clockwise rotation. So when the current is moving up, it is an anti-clockwise magnetic field. So that is how we use the corkscrew rule. When a corkscrew is rotated in such way that it moves in the direction of current flow, then the direction of rotation gives the direction of the magnetic field lines. Another rule can be used to identify the direction of the magnetic field. What is it? We use the right hand grip rule. So here, if this is the conductor, you place the thumb in the direction of the current flow, and when you fold the rest of the fingers, that shows the direction of the magnetic field. So when current is flowing up, it is going to be anti-clockwise magnetic field. If the current is flowing downwards, it's going to be clockwise magnetic field. You can remember that. Then, a force acts on a current carrying conductor placed in a magnetic field. That also we have discussed. So you have two magnets, in between you keep the magnetic field. So the current and the magnetic field, they are perpendicular to each other. Perpendicular to both of those, there will be a force acting on the conductor. This force is directly proportional to three factors. You can remember that. Current flowing through the conductor, length of the conductor, and the strength of the magnetic field. So when you increase the current flow, the force increases. When you increase the length of the conductor or the number of turns of the coil, the force increases. And when the strength of the magnetic field increases, also the force increases. Fleming's left-hand rule can be used to find the direction of the force acting on the conductor. So there we can use the direction of the force acting on the conductor. Then according to Fleming's left-hand rule, when the thumb, index finger and the middle finger of the left hand are oriented perpendicular to one another so that the middle finger points in the direction of current flow and the index finger is pointed in the direction of the magnetic field, the thumb is pointed in the direction of the force acting on the conductor. So you hold the hand like this, the middle finger, that is the middle finger, it is the direction of the current flow, the index finger is the direction of the magnetic field and the thumb points to the direction of the force. So then of course you can find the direction of the force. The operation of instruments such as direct current motor and the loudspeaker are based on the force acting on a current carrying conductor placed in a magnetic field. So you can remember the direct current motor and the loudspeaker, they are based on force acting on a current carrying conductor placed in a magnetic field. In addition to this, you can remember the analog voltmeter, ammeter, they are also based on this, even the galvanometer, the center zero galvanometer. So that is the first part of the summary. We'll continue in the next slide. In the operation of a motor, electric energy is converted to mechanical energy. Electric energy is converted to mechanical energy in a motor. It is a direct current motor. You can remember that. The generation of an electromotive force in a closed circuit due to a variable magnetic field is known as electromagnetic induction. So that is the opposite of the previous one. The magnitude of the induced electromotive force depends on the number of turns in the coil, the strength of the magnetic field and the speed of the moving magnet. So here also it is directly proportional. Magnitude of the induced electromotive force depends on the turns in the coil, strength of the magnetic field and the speed of the moving magnet. So when they increase, number of turns increases, electromotive force increases. Strength of the magnetic field increases, electromotive force increases. When the speed of the moving magnet increases also, the induced electromotive force increases. Then, in order to find the direction of current flow due to the induced electromotive force in a straight conductor, Fleming's right-hand rule can be used. So, you use the Fleming's right-hand rule. Here also, we use the right hand with the thumb, index finger and the middle finger held perpendicular to each other. Here also, you can remember this is the direction of the force or motion. How the conductor moves, then the index finger is the direction of the magnetic field, then you will get the direction of the current flow. According to Fleming's right-hand rule, when the thumb, index finger and the middle finger of the right hand are oriented perpendicular to one another so that the index finger is pointed in the direction of the magnetic field, the thumb is pointed in the direction of motion, then the middle finger points in the direction of the current flow through the conductor. So there, bicycle dynamo, moving coil microphone and the transformer are instruments whose operations are based on electromagnetic induction. So we have discussed all these: bicycle dynamo, moving coil microphone and the transformer. With that, I'll move on to the next slide. So a current whose direction does not depend on time is a direct current. So we have discussed that also, direct current and alternating current. So direct current, the direction does not depend on time. A current whose direction depends on time is an alternating current. So actually the direction changes with time. Dry cells and solar cells produced direct currents. So we have discussed that also. We have observed that as well. While the alternating current dynamo, that is alternating current dynamo, produces an alternating current. Using a transformer, an alternating voltage can be changed from one value to another. So based on that, there are two transformers, the step-up transformer and the step-down transformer. And the relations between the primary and secondary coils of a transformer is given by this. Here you can see this is one relationship that is used to determine the potential difference of the secondary coil. So here it is given in the other way. Now, so far we used number of turns in the primary coil, number of turns in the secondary coil equal to potential difference of the primary coil divided by potential difference of the secondary coil, and we rearrange. But here it is given in the other manner. So earlier we used this equation, students, you all can remember. Now when I did the calculation also, N primary divided by N secondary equal to V primary divided by V secondary. So we can rearrange these to get this equation. It's the same because it's a ratio between the two. So here we have primary up and secondary below it. Here we have V secondary divided by V primary giving rise to N secondary divided by N primary. So you rearrange the equation to get this one. So both are okay. When I did the calculation also, I used this equation, I rearranged it to get the secondary coil, the potential difference, voltage of secondary coil. Here you can substitute and you can find the voltage difference. It's the same thing. The same way, we have this equation where you have the V primary into I primary, that is voltage into current is the power. Power supply to the input coil equals the power of the output coil. So they are Vs into Is, and we did calculations related to this. So I am sure, students, with all these discussions, you all have a very good understanding of this particular lesson. So with that, I am going to end this chapter, and in the next chapter, I will discuss the questions given in your textbook.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.